In this video, we're going to talk about measures of central tendency. So when we look at the distribution of data, we should consider shape, center, and spread. In the last chapter, we identified the shape of the distribution of data through the use of histograms. In this chapter, we will discuss the distribution of data's center and spread. This section will focus on the center of a data set. So the measure of central tendency is numerically describes the average or typical data value. Often the average describes the mean, but that's not always going to be the case. So the three measures of central tendency are the mean, the median, and the mode. The arithmetic mean, or just the mean, is when we add up all of the values and divide by the number of observations. Keep in mind, we want to be able to round the mean to one more decimal place than the data values are. For the population mean, its symbol is mu, Greek letter mu. Okay? And this particular symbol is what is called sigma notation. Another way to say that is summation notation. And summation notation means taking its sum. So you add up all the data values and divide by the number that's in the population. The sample mean is pretty much the same formula. You add all the data values that are in the sample and divide by the number of data values that are in the sample. This symbol is X bar. The median is the value that lies in the middle of the data when arranged in ascending order, meaning from least to greatest. And the mode is the value that occurs the most in a data set. All right, so let's take a look at the first example. We want to calculate the population mean, the median, and mode for the data set below. The first thing we're going to do is we're going to list these data values from least to greatest. And I've written that below. So the first thing we're going to do is we'll figure out what the population mean is going to be. So let's write that out now. So what do? We add up all the data values and we divide by 7. Putting that into the calculator and rounding to one decimal place, we get approximately 10 3/10. Now, let's talk about the median then. So the median is the data value that is in the middle when arranged from least to greatest. So in this case, there's only 7 data values. So the value that's in the middle is the 4th data value, which in this case is 10. Now, let's talk about the mode. The mode is the number or the data value that occurs the most frequently. Well, in this case, we end up having 2, right? 8 occurs twice, and so does 12. This is a data set that is called bimodal. All bimodal means is the data set has 2 modes. If the data set has 3 modes, then it's what is called trimodal. Okay, let's take a look at the next example then. So now we have a sample of 8 test scores and it's a statistics course. I want to calculate the sample mean, median, and mode. First thing we're going to do is we're going to list these data values from least to greatest. Okay, so now that I've listed them from least to greatest, let's calculate what the mean is going to be. So let's do that now. Now notice I'm using the symbol for the sample mean, which is X bar. Okay? So when I add these up and divide, I get approximately this. Keep in mind I'm rounding to one more decimal place than the original data values. Because the data values do not contain any decimals, I want to use one decimal place. All right, now let's take a look at the median then. Well, the median then is going to be the middle data value. The problem is, in this case, I have 8 data values. So that means there's not going to be just one middle value, there's going to be 2. Okay. So what am I going to do if I have 2 values that are in the middle? Well, I'm going to take the arithmetic mean of it. So the mean, I'll take 70 plus 72 divided by 2. That's 71%. Okay. Now, the mode. In this case, because every single data value occurs once, there is no mode for this problem. Okay, let's take a look at the next example. So now I'm going to change the previous example from that 0 that we see up there, and I'm going to change it to a 70. I want to be able to calculate what the mean and the median is going to be. Okay? So first of all, I'm going to write these values from least to greatest first. Okay, now let's take the sample mean for this. So again, we're still using X bar because it's a sample, and everything is pretty much the same, except instead of that 0, we replaced it with a 70. So add up the values and divide by 8. That is approximately 75 4/10%. Now, for the median, we still use the two middle values. Well, that does not change at all in this case. So it's still 70 plus 72 divided by 2. That's still a 71%. Now, is the mean sensitive to extreme values? When I got rid of that 0 and put in a value that's a little bit closer to the rest of the data values, what happened to the mean? It increased by 10 percentage points. When you're talking about out of 100%, that's a big deal. That's one letter grade. So is the mean sensitive to extreme values? Yes, it is. Okay? Now, let's take a look at the median. When I got rid of that extreme value and changed it to a 70, okay, did that change the mean? In this particular case, it didn't. So is the mean sensitive to extreme values? And that answer is no. So a numerical summary of data is resistant if extreme values relative to the data does not affect its value substantially. So is the mean resistant? No. Our mean changed by almost 10 percentage points in this case. So no, the mean is not resistant. Is the median resistant? Yes, because it stayed exactly the same, even though we got rid of that extreme value. Now I want to talk very quickly about the distribution, comparing the mean and the median. So when data is skewed, there are extreme values in the tail which tend to pull the mean in the direction of the tail. Okay? So the distribution is going to be skewed left if the mean is less than the median. Okay? The distribution is symmetric when the mean is approximately the same as the median. Okay? And the data is skewed right. If the data is skewed right, then the mean is greater than the median because we have extreme values that are to the right. Okay? Now, be careful. The relation between the mean, the median, and skewness are guidelines. The guidelines tend to hold up well for continuous data, but when the data are discrete, the rules can easily be violated. Well, then the question would end up becoming, why would you ever want to compute the mean? Well, let's take a look at some reasons why. The biggest reason is because the mean uses all the data values in the data set, while the median only uses 2 data values. All right, so when should you use the mean and when should you use the median? Well, you should use the mean when the data is quantitative and the distribution is roughly symmetric or bell-shaped. In other words, if the mean is approximately equal to the median, then you should use the mean. Why? Because, again, the mean uses all of the data values while the median only uses 2. You should use the median when the data is quantitative and the distribution is skewed left or right. So in other words, if the median does not equal the median, then we should use the median. Okay, so let's calculate what the population mean and median would be, and then let's try to just determine which would be better to use for the data, the median or the mean. Because this is the population mean, we're going to use mu for this. So add up the data values, divide by 5, that's a 59. Well, the median's very easy because I only have 5 data values. That is going to be a 75. Well, again, if we're doing this out of 100, well, there is a big difference between the mean and the median in this particular case. I would probably use the median over the mean in this example. And that 0, that extreme value does make a difference when your data set is very small.